Hello. In this lecture, I am explaining a problem that is very important to understand when dealing with the properties of material, especially elastic property of the material. So this problem is related to basically with the calculating the pressure in bulk modulus. So the problem is how much pressure would be required to compress a quantity of mercury by 0.010 percentage. So actually nothing is given. We have to find the pressure and it's the material is mercury. So what is the external pressure to have compression of 0.01%? Because of the compression, the mercury will be contracted, compressed to 0.010%. Okay, we should know the bulk modulus of mercury. Bulk modulus of Hg, which is mercury, is 2.6 into 10 to the power 10 Newton per meter square. I can use this data later. So what is formula for bulk modulus? The bulk modulus B is negative sign delta P divided by delta B divided by B naught. So delta P here is the external pressure. External pressure. Okay, and delta P is change in pressure. What is B naught? B naught is original pressure, original volume. I'm sorry, this one is not a pressure, this one is volume, change in volume, and this one is original volume of mercury. Okay, so volume. Okay, so these are things. Negative sign here is introduced because bulk modulus B is positive, the pressure is positive quantity, but this delta V is negative because when you put pressure on the mercury, suppose that this is mercury, right? If you put pressure from all the side, what will happen is, suppose that initial volume is B naught and final is V. What is the change in volume is final minus initial. So what happened when you compress this one is initial volume will be larger than the final one. This means you are getting some negative number here, negative number. So delta V is negative. Okay, that's why to make B positive, B means bulk modulus, we have to introduce negative sign in the formula, and that's why here it is. Okay, so our goal is to find delta P, how much pressure is required. So let me rearrange this equation so that delta P is equal to negative of B delta B B naught. We don't know initial volume, we also don't know final volume, but we know how much is the quantity of mercury contracted, compressed, that is 0.010 percentage. So what is that? That is delta V by B naught is given, right? 0.01 percentage. So this is given. So converting percentage to the number, you have to divide by 100, right? This gives you, when you divide 0.01 by 100, you will get 10 to the power negative 4. Okay, so this is delta B is equal to 10 to the power minus 4 B naught. Okay, so this is negative because change in volume is negative, that is volume is decreasing, that's why um, we have to take this one negative. If you put this number in this equation, so suppose that this is equation 1 and this is equation 2, putting values, plugging value from equation 2 in equation 1, you will get delta p. Delta p is equal to negative p. Delta v is negative 10 to the power 4 p naught divided by p naught. This v naught here is already there, so b naught and b naught can be cancelled, and this negative sign, here will be also cancelled, and you will be ended up with delta p equal to b into 10 to the power 4. Okay, and we know b, which is the bulk modulus of mercury, 2.6 into 10 to the power 10 newton per meter square. So delta p equal to 2.6 into 10 to the power 10 newton per meter square multiplied by 10 to the power, this was negative, sorry I put positive, so that was negative sign, right? Okay, from here we will get delta p, because this is 4, this is 10, 10 minus 4 will give you 6, so I can write down 6 here. Delta phi is equal to 2.6 into 10 to the power 6 newton per meter square. So to compress mercury by 0.01 percentage, 0.010 percentage, we have to apply a pressure of 2.6 into 10 to the power 6 newton per meter square. Okay, the pressure, unit of pressure is newton per meter square, because pressure is the force per unit area, and this is newton per meter square. We have at the bottom in the formula is delta b by b naught. This is the actually volumetric strain, because volume is measured in cube, change in volume, and original volume also metric cube, that one is cancelled. So unit of pressure is just newton per meter square. Okay.